practice test, and I'll work on this sheet. I'll save it. I'll post it onto YouTube. You guys should correct with a color pen. Take it home and study it. If you have somebody at home that helps you study, then you can show them this, your copy of it. And then if there's something you're stuck on, you could go to the YouTube and maybe re-watch it. And then I think that would be really helpful for you. Sammy.
So the test is going to be like pretty much the same?
It's going to be similar format, same types of problems, but remember, there'll be some application problems involving like money, a word problem. And I ended up not putting order of operations. I'm going to just wait till our next test, so you have enough time tomorrow. I didn't want to cram so much on there. Okay? So let's just go through. I'll call on you guys, and we'll talk about what the correct answers are and why you picked what you picked. Raise your hand if you can tell me what you got for number 1. Okay, Eric? You've got G. Okay, so let's take a look at G and see if that makes sense. So right now I'm going to write that down so we can check it. So G, you put the expanded form. So 300, and then this decimal means and 27,000 hundredths. So there's the 27 hundredths when you add it together. That's correct. So I'm going to cross G out like I was taking a test, because then I can't use that again. I'm not going to scribble it out, because if I made a mistake, I still want to see what it is. But so far, raise your hand if you agree with G. Good. You guys, that's correct. Okay, Sasha, do you have the next one?
Yeah. Okay.
Right. So even though this is a decimal, 5/10, it also represents 1/2. And I don't know if this was the class that we played around with this picture over in K, but if you look at K and you take these triangles, if you think about these triangles, one thing that you can do is imagine sort of rearranging the picture with these triangles. So I'm going to imagine taking the triangle from up here and moving it to here, and then that gets rid of this triangle. And then taking this triangle up here, and imagine it sliding down here, and that gets rid of this triangle. And so what you're left with on the bottom, right, this whole section, this is half of the whole square. How many people did it like that? I saw some kids thinking that way yesterday. That's great. Now you don't have to do it that way. Some people just could visualize that that was half. Okay, so I agree with Kay. Kay's a great visual problem. I'm going to erase the picture so we just get back to what it looked like, in case we need to do any changes. But that's a good way to think of that. Okay, what about the third problem, number 3? Isabella, what did you do?
Well, I got L.
You got L. And how did you get L for this problem? I agree with L. Can you share with the class how you did that?
I did 4 times 6.
Right, so when you do 4 times 6, what do you get? You get 24. So if it's 4/10 times 6/10, there's 2 decimal places, so you move in, and then how do you say that answer? Hundredths, and this is a hundredths plate, and you have 4 by 6 here, so you have 24 little squares shaded, so that's 24 hundredths. So L is correct there. Okay, who can use powers of 10 to explain the next one, number 4? Nick? On number 4.
Well, you divide,
when you divide by a number that's
smaller than one whole, it gets bigger.
Good. So I don't know if you guys heard that. When you divide by a number that's smaller than one whole, the original number, this number, is going to get bigger. By how many powers of 10? By 1. So that decimal is going to move one place to the right. So it becomes 327.
And that's it.
And that is A. Good job. Somebody new. Who can do number 5? Okay, Claire. What is number 5? Say it in words for me. Can you say that in words for me? 300s, right? You did. That's right, because this is a hundreds plate right here. So there's 100 squares, and 3 of them are shaded. So we'll cross M out. That's correct. Good job. Sammy. What about number 6? So E, 236. So far so good. 236. And, so that's the decimal point. This is tenths, hundreds, thousandths. So 14 thousandths. Perfect. E. So we'll cross E out. Who can do number 7? Somebody new. Kyle, we haven't heard from you.
I think I got J.
How come? You're correct. It's J. How is this 1/10?
Well, if you count the lowest square, well, actually, an easy way of doing it is that you can move them all in one row.
You could imagine them all moving to one row, couldn't you? And if you did that, there would be 10 in a row. So you would have one shaded row, if you imagine what Kyle's saying. And that would be one shaded row out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. So 1 out of 10, which is 1/10. That's a great way to think of it. How about number 8? Andy. C. Perfect. So when you see 2.5, you're thinking of that 0.5 as what? A half, right? And so C is the correct answer there. How about number 9? Quinn? I. 9. I. Where is I? Yes. So we've been working on those benchmark fractions. 75 cents. You can think of this as 75 cents. 3/4 makes 75 cents. 3/4 is the same as 3/4. So I. Or you might just have that memorized as one of your benchmark fractions, which is great. Why is it underlined? I just didn't do a great job proofreading when I made this quiz. It was an accident. It's not supposed to be special. Sasha. For 10? Yeah. 2/10 is B. It's 1/5. And in fact, if we scroll down a little bit to look at the bottom, number 13, we can sort of show that because this is 1, 2, 3, 4, 5. So this is a number line of fifths. That's 1/5. Which, if you think about this up here being a decimal of 1 whole or $1, when I take it to dollar and break it into 5 equal parts, I get 20 cents. So that shows us that 2/10 is the same as a fifth. So even though it was on a problem up here, sometimes on the test, when you see a problem like this, if you're not sure, maybe you can look farther down for some hints. And that might help you. So 2/10 is a fifth. Good job. Good job on the matching. Any questions on that? Should we keep going? Okay. So who can do the first number line? Jackson, start me off with that. You counted eighths. Isabella, did you count eighths too?
Yeah.
Yeah. So let's just, I'm going to pick a little bit lighter color so it doesn't get too busy here. So if you didn't, you might want to double check. 1, 2, 3, 4, 5, 6, 7, 8. And so that makes this 1/8, even though that wasn't one of the things you had to fill in, it really helps. Do you know 1/8 by memory?
Yeah.
So how could you do it if you don't? Claire, do you know it by memory or do you have a process? Okay, who has a process to do it? Cannon.
Well, another one that might also, I just know that 8, you can also put it in fourths.
And that's what
25 cut in half.
Okay, that's great. I think that's great. So let's talk about what that looks like here. If I take a different set of jumps, you could cut 8 into fourths. So for you guys that are still working on this, when you cut this into fourths, this is a fourth. It's also correct to write 2/8, but what Cannon's point is, most everybody knows a fourth is 2 2500ths or 0.25. And then if you put this to be 250, why did that help you, Cannon, become able to memorize these?
And then if you do 125, those 125, and it's 250.
Right, if you divide 250 in half, you're going to get 125.
You wrote 2 fourths, not 2/8.
Oh, thank you. Good job paying attention. Let's fix that. Oh, it's good to see a little bit of mistakes on recordings. Then you can show your parents that you're really paying attention and that you caught my mistake. That's kind of fun, isn't it?
Yeah, it's fun that.
Right. It's also good to remember that, I hope you guys understand, like, when you're working on a problem, if you make a mistake, that's really normal, right? So it shouldn't make you nervous. It should just remind you to refocus, just like I need to refocus right there. So that's a good thing to watch. So let's go back to what Cannon was saying. If you take this 250 tens, hundreds, thousands and divide it in half, you're going to get 125 thousandths. And that's going to make all of these easier. Sammy? You're going to do the next one. Okay, so let's move on down the line. Can you do this for me, this part right here, this fraction? 1/2 or 4/8, even though it's not asked for that, it's really helpful to have that one. And what would the decimal for that be? 0.5, and let's think of it as 3 decimal places, especially for people that are still practicing. Then what am I going to do to get to the next one? How do I get to this? What's this going to be right here? Sammy, keep going. 5/8. Good. And this one? 6/8. Can you think of another way to write 6/8? 3/4. And if you look at these light blue jumps, there's 3 of these. 1, 2, 3 out of 4. So do you know the decimal for 3/4? 0.75, 75 cents. Okay. Perfect. If I asked you this decimal, if I put a box here, how much would I have to add to 0.75 or to 0.750? Somebody knew. Haley. Yeah, I would have to add this, right? This is one size jump, so I'd have to add that 0.125. So 0.125 plus 0.750, 578, so it's 875 tens, hundreds, thousands. Perfect. Okay. Let's do 2 more number lines and then take a quick break. Okay, so how about, who haven't I heard from?
No. There's no me yet.
Michaela, can you count the jumps for me right here? There's 3 jumps, right? So what fraction would this be? 1/3. Perfect. 3.3 repeating. Perfect. And so this is 2/3. Right. Great. Okay. How many people got that one? That's a great one to memorize.
I think it's fun.
Yeah, these are good. Let's take a break. We're gonna just take a break here. Okay, good break. Let's keep going. Okay, so let's talk about powers of 10. We started this in the other class, but going back to powers of 10 here. When you multiply a number by 1,000, does the original number get bigger or smaller? Bigger. Bigger by how many powers of 10? 3. So that means that decimal place moves 1, 2, 3 times. So Haley, what do I do with these here little spaces? Yeah, what should I put here? Zeros. Okay, I'm gonna wait till I have everybody's attention. Okay, good job, Haley. So 3500, so it's 3,500. Can you keep going on this one, Haley?
Yeah.
So now is the number going to get bigger or smaller when I multiply by tens, hundreds, 1,000? Smaller, good. By how many powers of 10? So it's tens, hundreds, thousands. 3, right? So I'm going to take my decimal, which would be at the end now, and what will I do with it? Which direction? Right, so 1, 2, 3 powers of 10, so I'm back to 3.5. Okay, last part, Haley. I'm going to take 3.5 and multiply by 10. Is the number going to get bigger or smaller? By how many powers of 10? It's going to get bigger, right? 1. So my final answer should be 35. Does that make sense?
I don't know. I got 35.
How many people got 35? Okay. So you had 0.35? No, 35. 35 is correct. Okay, should we do the next one?
He's calling me Kay. Because he's calling me Sarah.
So, class, it's time for us to refocus after that break. We ready?
Yes, we are.
Sasha, can you start for me? If I take 18 and I'm going to multiply by 1/100th, I'm going to divide by 1/100th. Is my 18 going to become a bigger number or a smaller number? By how many powers of 10? 2, so my decimal goes here, and I have to move it which way? 2 spaces. So what am I going to do with those 2 spaces? Perfect. So this is 1,800. Okay, Mark. I'm going to take 1,800, and I'm going to divide by 1/10. Is my number going to get bigger or smaller?
Bigger, it'd be 18,000.
Yes, it would be 18,000. Okay. Isabella, now I'm going to take 18,000 and divide by 100. Is my number going to get bigger or smaller? By how many powers of 10? 2. So my decimal goes from here twice. So my final answer is 180. Okay? Turn the paper over. Okay, I think as soon as I have your attention, I'm going to skip to problem 20 right now because I think the last set might be more challenging than, or should I maybe do 18 first? In other words, I'm going to skip around, and if I don't finish it, I'll finish it later and post it. But I think more people maybe need a little reminder on some of these problems from 18 on.
Reminder of course.
Yes, I understand. So that's why we're going to do that.
It's about like 2 minutes of each problem.
Yeah, that's true. So remember, you can fast forward if you watch this at home. You don't have to watch all the things you're good at. Okay, I'm going to use the area model for multiplying. So for those of you that need a reminder, you're going to take your number, like 3.5, and break it into the whole and the decimal. And actually, I'm going to put the 3 on the side. Just, it doesn't matter at all. It's just 3.5 is a little smaller than 4.6, so it looks a little bit better, but you would get the same answer either way. Good question. Now you have 4 spaces. So do you see these 4 spaces here, the different little rectangles? There's this rectangle here, and then there is this rectangle here. So you're kind of looking for the different rectangles, so you can see that there's 4 values that you're actually trying to find. Okay. Oh, that one's kind of ugly. But anyway, there's 4 different values. So it's 4 multiplication problems. Claire, you want to do it? Okay, so what goes in this area right here? 12, because 3 times 4 is 12. Okay, what goes here, Claire? Okay, so first you do 4 times 5 is 20, and then there's 1 decimal place, so you're going to go in, so you're correct, it's 2.0. Do you see that? And then 3 times 6 tenths is 1.8, because 3 times 6 is 18, and we've got that 1 decimal place, so we're going to move back 1 decimal place. And then 5 tenths times 6 tenths is 0.30. Perfect. Yeah, maybe I didn't pick great colors. So now I'm going to add up all of my parts. So 12 plus 2, if I add these in my head, I get 14. Then I'm going to add 1.8, which means I need to line up my decimals. I'm going to put a placeholder there. Then I have to put a 0.30 here. So you could add zeros here, or you actually don't even need those zeros, but I think it helps 6th graders to put those zeros in. So let's see, Marcos, add for me. What do I get here? 0. What about here? 11, carry the 1. Perfect. Decimal place? Right. So for adding and subtracting, your decimal goes straight down. So final answer, 16.1 or 0.10. Okay? Raise your hand if that helps. Okay? How many people already understood it? Okay. It's good to review even when you understand it. Okay, let's do traditional multiplication over here. So if I were going to do traditional multiplication, I would put the number with more digits on top. Who can do this? Jackson, start me out. Yeah. Nope. Start me out, Jackson. 18. Carry the 1. 6 times 12. 6 times 2 is 12 plus 1 is 13. That's right. Carry the 1. 5 times 6 is 30 plus 1. What happens next? Placeholder. Keep going. 1 times 3 is 3. 1 times 2 is 2. 5. Keep going. You're going to add 8, 6, 3. Talk to me about decimals. It would be because you have 2 decimal places. You're going to move in from the right between the 3 and the 6. Okay, so this is 83 and 68 hundredths. Let's jump to the area at the bottom of the page. Sammy.
Last time, on the problem number 19, I got totally different, answers, but then I got the same ending answer.
That's okay because you set it up in the reverse order, right? So if you did what Sammy did and you put the 16 on the top and the 5.23 on the bottom, your numbers here are going to look different, but in the end you should still get the same answer. That's okay. Okay, we're going to go to the bottom of the page. Oh, look it. Also study order of operations. I took that out. But you are going to have an application problem. It's like a word problem involving money and buying things.
I'm not good at that.
Well, practice the ones we had in our book yesterday. Remember those? And Sasha, you can come in tomorrow morning. I think you'll do great. Okay, let's do the harder. Well, can we do the harder one? Do you understand area and perimeter for a rectangle?
Yes.
Okay, so let's just quickly get the perimeter. What was the actual answer? Yeah, Kyle.
Why is there a random line? That's not on our papers.
Here, this? Yeah, because I make these and sometimes it's just not perfect.
Well, I got the perimeter with 32 areas.
So you got the perimeter is 32. That's right. Because 6 plus 6 is 12. Add 10 plus 10. So your perimeter is 32. And your area is 6 times 10. So that's 60. But talk to me about units. Don't I need units here? 60 what? Squared centimeters.
You could just put a 2, right?
Yeah. Square centimeters. And 32 what? Centimeters. Okay. So this is the harder problem for some people right here. Is that true? This one right here?
Not really.
What do you do, Nick? That makes it easy for you.
In each in double shape, I make 3 triangles.
Do you mean 3 rectangles?
Rectangles.
Right. So I've made 3 rectangles like you. Can you tell me how long this is? Because it would really help me. It's 5. Because this is 2. So that's this far. That's 2. This is 1. So 2 plus 1 make 3. So now this is 3 long. And this is 2 more. So that's 5 altogether. So this is 5. Raise your hand if you see that, because that's kind of the key to the problem. Jackson, you got that? Not yet. So let me try it another way. So if I take a different color, okay. So can you see this distance from here to here is 2 units?
Yeah.
And then this distance from here to here is 1 unit? Just 1? And then this distance from here to here is 2 units? So I have 2 plus 1 plus 2. When I add those up, I get 5.
Yeah.
Does that help? Okay, so I'm going to get rid of some of these lines for a minute because it makes it a little crazy. And just put back in the key lines. This was 2 by 5. So Jackson, now 2 times 5 gives me the area of the tall rectangle. So it's 10. Okay? So this one's 1 unit by 2 units. So what's the area of that? 2. And then Sasha, can you do the middle one?
Yeah. Well, so
How much is this from here to here?
it's
Okay, how about from here to here? It's 3. So the total, 6. So the total area, what do I do? Sammy. Add 10 plus 6 plus 2. Perfect. So that's 18. And what are the units? 18 centimeters squared. I think we have time to do the perimeter and then it's time to go. Isabella, you want to help with that? Okay, so perimeter, I'm going to clean this up, but put back in what we already found out, that this was 5. We already know this. So tell me how you do perimeter. Hang in there for a couple minutes, guys. Isabella, what's your approach? So she adds up both sides, so we're going to do 2 plus 2 here, right? Plus another 2 right there. Plus this 1. Plus another 1 for right here. Oops, I meant that to be blue. Plus this, which is 2, plus what's the bottom? It's 5, right? 1 plus 2 plus 2 is 5. And this one right here, 5. So your perimeter is, what's 2 plus 2 plus 2? 6.
Oh, that's a times sign.
Well, it's a sideways plus there. Okay, plus 1 is 2. That's these. And what's 2 plus 5 plus 5? What does 2 plus 5 plus 5 add up to? 12. So when we add 6 and 2, Michaela, what do you get?
6.
And 8 and 12?
I lost one of those. Yeah, 8. No, 16.
Add 8 and 2 first.
8 and 2 is 10.
So 10 and 10 make,
10 and 10.
so 8 and 12 is 20.
Oh.
20 centimeters. Okay, so I'm going to pause that